The next section here is data preprocessing, which is often the longest section in data projects. The first is label encoding. This essentially changes words into numbers so that our model can recognize it and be trained on it. So first we define our mapping. So we say, where we see low, we want to change that to 0. Where we see okay, we want to change that to 1. And when we see high, we want to change that to 2. We then apply that mapping to our target column, which is cholesterol, LDL human. So just for your information, all the blocks here are already ran just to save time. But if they haven't been ran, make sure that you're pressing the play button on each of the cells. We then define our input and target variable. So for this, we use all variables that have the word absorbance in them. So if we look back here at our table, we use all of these absorbance columns, and we also use temperature and humidity to predict LDL cholesterol. And then we define our target feature as the LDL cholesterol level. We then split our data into a training and test set. So here we use a 20% test set and a 80% training set, and we use the train test split function from the scikit-learn library. We also stratify, meaning that the same proportion of low, okay, and high levels of cholesterol in the training set is also used in the test set. We also set the random state to be 42, just to ensure that we have reproducible results. The next section here is feature selection, and the whole purpose of this is to identify which features are most predictive of LDL cholesterol, in our case, which absorbance values and temperature or humidity will be most predictive of LDL cholesterol, identifying those and just using those in our model. The issue with using all of the features in our model is it can lead to something called overfitting, which is explained in more detail in the link here. The feature selection method that we use for this project is using a random forest classifier to identify which features are most predictive of LDL cholesterol. So we import this classifier from the scikit-learn library, we configure the model and fit it to our training data. We then use this select from model function that enables us to select the important features, and feature importance here is judged based on the mean decrease of gene impurity. If you're not familiar with this term, I would recommend looking at my video on decision trees explained. We then identify the features and print them, so we can see the selected features printed here at the bottom. So we can see here that some absorbance values have been omitted, such as absorbance 1 and absorbance 2, but we can see here that absorbance 3 was selected, absorbance 5, so on and so forth. So these are all the important absorbance values for predicting LDL cholesterol. And we also have here at the end, temperature and humidity were selected as important as well. We then transform our input data for both the training set and the test set just to select these important features. So the next section here is all about standardizing our data. So different variables have different ranges. So for example, absorbance readings are usually around 0.2 to 2. Humidity is between 17 and 63, temperature between 30 and 53. So with a deep learning model, it's important that these variables are on the same scale. So the model pays equal attention to the small absorbance values and the bigger humidity or temperature values. So this essentially puts all of our input features on the same playing field. To do this, we use the standard scalar function from the scikit-learn library, and we apply it to both our training set and our test set. Very important that whatever pre-processing step we do, we apply it to our training and our test set. The next section here is dealing with the imbalanced data. So in the data exploration section, we saw that the number of low LDL cholesterol levels were considerably low. And so we want to make some synthetic data so that our model pays equal attention to each of our target labels. So here we import SMOTE, and I do have an article explaining this. So it stands for Synthetic Minority Oversampling Technique. And this is imported from the Imbalance Learn library, and we apply it to our scaled training data. We don't apply it to our test data because our test data should all be real values. We only apply it to our training data to increase our model's performance. So we apply this method and print the frequency of each of our labels. And we see here that for each we have 5,856 high, okay, and low levels of LDL cholesterol. We can then do a bar plot, and I won't spend too long on this, but we use the matplotlib library, and we can see here our real data and our synthetic data. So we now all have around 5,800 labels for each. We can also build a pre-processing pipeline to store all of these steps. So if we get a new batch of data and we want to apply our pre-processing steps, we can just apply this pipeline and it can do it in one go. The next step is one-hot encoding, and this is for our deep learning model. The image here demonstrates how this works. So we can see here that we have low, OK, and high levels of LDL cholesterol. Essentially, a column for each of these are made, and wherever that row has low, a 1 is put there. Where it has OK, a 1 is put underneath OK, corresponding with that row. So this is the second row, so this is the second row, and the same for high. And then we do this for all of our samples. So if the next one was OK, then we'd have a 1 here. The next one was high, then we'd have a 1 here, and so on and so forth. This is done as our deep learning model requires our data to be in this format to predict these labels. So we import the one-hot encoder function from the scikit-learn library. And you might have noticed in this project, we're importing a lot of functions because we don't want to be building these from scratch. We want to save time. And we apply it to our target feature. So this isn't our input feature, it's our target feature, which we stored as y-train balanced from the previous section. And we also apply it to our target feature in the test set.